Good morning, good morning, good morning. I hope everyone is happy and healthy. Today we are going to practice some areas of polygons. So I need to, this is going to be a brief video. It's just kind of hints and suggestions for those of you who are not in the classroom or who have been absent today. So one thing I want to kind of keep in mind for trapezoids. Number 2 is a trapezoid. If you remember from back forever ago, you could cut a trapezoid right here and take this triangle, spin it around, and put it right there. So you can quite literally turn this trapezoid into a rectangle. That's no longer here. And if you're finding the area of a rectangle, remember that it is simply base times height. Now the problem is you need to find the average of these bases. So you have to find, it's not just going to be regular base times height, it's going to be the average of the bases times the height. And that's what you're going to do for every single one of the parallelograms or trapezoids. You can do the exact same thing. I said that I would help on number 7. So number 7, we are going to use the apothem. That is number 4. 4 is the apothem of this pentagon. So when we use the apothem, what we're doing is we are actually going to find how many triangles can be created. And I can see that here is one triangle that has a base of 9, because all of them are the same, and a height of 4. So to find the area of a triangle, it is 1/2 base times height. And the apothem is actually the height of that triangle. So it is 1/2 times 9 times 4. Half of 4 is 2. So the area is 2 times 9, which is 18. The area of one triangle. Then the other pieces, you've got to then figure out how many total triangles you have and multiply this by the total number of triangles you have. I said I would also help with number 11. So if you kind of think of this like a radar, it's got a 60-mile radius. So to find the area of any circle, A equals pi r squared. The radius is 60, so the area is equal to 60 squared times pi, which equals 3,600 pi square miles. And I'm going to leave it like that because there's another step to this. If there's a mountain that's blocking it, so we have a mountain here blocking 18 degrees of this signal. We need to figure out what portion of the circle it is. So 18 degrees, that's the part over the whole. And we know that the whole is 3,600 pi. This is going to be the part that the signal does not reach. Pretty simple, right? Number 13, I put on here because it's covered in this area and it is an example of an SAT or ACT question. So I found it very interesting. I spent quite a bit of time on this. Couple things you kind of need to know. So in this figure, arc SBT is 1/4 of the circle. Okay. So to find this, it's 1/4 of a circle. And to find the circumference of a circle, remember it's 2 pi r. Don't know why I put equals. It is times 2 pi r. Now the radius is 6. So this is 1/4 times 2 pi 6. 6 times 2 is 12, and 1/4 of 12 is 3 pi. So that arc is 3 pi. So what we have to figure out is this side, and this length. Well, interestingly, or to many of you it's not interesting at all, but I found it interesting. Remember the diagonals of any rectangle is equal to itself. So from the radius to the outside edge is, or from the center to the outside edge is called the radius of a circle. So that diagonal RB is going to be the radius of the circle, which is 6. That means that diagonal AC is also 6. So we know because this is a diagonal, it is also 6. Okay. Now it says if the length plus the width is equal to 8. Okay. This is where it gets, like, my mind completely, I blew my own mind. Okay. This is a radius, correct? Yeah. And this is a radius. So that is a total of 12. The green section is a total of 12. Now, that is going to be equal to, we know that this section right here is the radius minus the length. And this section right here is the radius minus the width, right? But we also have to include this section here, which is the length, and this section here, which is the width. I know this, I don't know how this works or why this worked. But you can see that we have the length and the width are going to cancel each other out. Since the length and the width are equal to 8, we're going to subtract one radius, or add one radius, or add one radius to it. It's just going to be 14 total. 6 plus our length and width. So the total area is equal to 14 plus 3 pi, or total perimeter. I found it totally fascinating. Anyway, you have number 13 solved. Number 14, this is a semicircle. I want to make sure this is a semicircle. This is the length of a square. So half of this is the radius of the circle, which means the radius is equal to 3. And once you find the entire area of the circle, make sure that it's 1/2 of it, because you only have half the circle there. And then this one, you're also going to use the apothem, finding the area of triangles. Areas of triangles. The homework. So when I used to teach this unit for in my previous school, I spent a lot of time trying to come up with compound and complex figures. So talking about a compound figure, this is where you add 2 or more shapes together. So like this would be a sucker, which would be made up of a circle, but actually done right, and then a rectangle for the popsicle stick. So you could decorate it to make it look more like a sucker and a popsicle stick, but that would be an example of one that you can't use. That is a compound figure because it is made up of 2 or more shapes. It's made up of a circle and it's made up of a rectangle. A complex shape is one where you are taking away part. You are either splitting a shape. So this is where you're going to include a semicircle, a half circle. So the example that I used to make was be a snow cone, which is a half circle, semicircle, and a triangle. This is a complex shape because it is a semicircle and a triangle, but because it's part of the circle. So if you were also to subtract something away, so like at one point SD cards look like this, but with a little corner out of it. So if you get rid of that and you had to find the rest of the SD card, that would be something that would be also a complex shape. Or if you take a hexagon, an octagon, and you take out part of it, that's going to be a more complex shape. So what you're expected to do for your homework is you are to create your own compound or complex geometric figure. Things that you need to remember to include: if it is going to be taken away or you need to just find part of it, remember to include shading if needed. You also, that's if needed. You also need to make sure you include all the necessary dimensions. Now, it can be ones where you have to find your own, but a necessary dimension would be the length here, width here, length here. The apothem, the radius, and the side length, or the perimeter. You could get all complex. Make us figure it out. You could use the perimeter and say this is an equilateral triangle. So I want you to get creative and make a compound or complex geometric figure that someone else will likely have to find the area of. Make sure you include shading if needed and any necessary dimensions. Make sure you submit this on Canvas.